All right, looks like I'm live. So I'm trying to figure out Restreamer and a few other options going on here. I should be live on both Twitch and YouTube at the same time. So I see some comments coming in. It looks like things should be working. This is the first time ever streaming on Twitch. So hopefully you can hear me. And otherwise, let me know what's going on, and hopefully this is working. Although I'm a little confused because YouTube isn't acknowledging that I have a live stream right now, but I do see this on Restreamer's live dashboard, and I do see it on Twitch. I've got one viewer right now on Twitch. So I guess I kind of got started somewhere between earlier and later than I meant to, but I'm testing out my new system here. And I just kind of wanted to try some stuff out. I have absolutely no idea what kind of lag I have with any of this stuff right here. But if this is all working correctly, then any of the chat messages that you all type in YouTube, where I know I'm going to have most of my viewers, are actually going to show up on the Twitch stream as well, and vice versa. So if the one person who's out there in Twitch land wants to comment, then, let us know what it looks like. And hopefully this will be interesting. So thanks for joining. Hey, awesome. First viewer on Twitch. Like I said, I wasn't even actually really ready to go live. I just hit start, and I kind of wish that Restreamer gave me a way of saying, hey, I'm not ready to go live yet, but cool. You saw it on YouTube and then moved to Switch. Awesome. Okay, excellent. So I've been working on this project with this team on this project called Open Studio for about 11 years now. And one of the things that this thing does is it's got this just massive set of swig bindings that are generated. Now, I see the overlay is not perfect here. I don't know what my options are for making that a little bit better. It's pretty small. Let's see if I can adjust that in any way. Maybe not right now. I'll have to play with that later. It's not going to be great. Yeah, I'm not surprised if Twitch latency is better than YouTube, because that seems to be the way these things go. So this project, Open Studio, is just like so hugely massive set of swig bindings. So I'm gonna do this LS right here. This is just actually I feel like the chat overlay is just gonna end up being annoying, but we'll see. This is one of the medium-sized swig wrapper bindings generated. Yeah, it's gonna need some alpha blended background. I totally agree. I don't know if I have the ability to change it on the fly. Let me see if I can do that, since this is kind of bad. All right, I'll see if I can fix that. So thanks for putting up with me on my my first foray into this new setup here, everyone. Remove that. Try adding it back in. All right, that's got a little bit bigger text and a little bit better blended background here. Maybe it'll make it show up a little bit better. Yeah, I agree. The chat overlay probably won't be missed for now, but I'll give this one quick shot, and if this doesn't look any better, then I'll just disable it. No big deal. Okay, so this project's use of swig is just crazy. So this is a debug build, and this is a 10 megabyte file that is generated by swig. And when I do a debug build, it's a 51 megabyte object file that is generated. And I started wondering, because of something that someone had said on Twitter yesterday, like, I've been working on this project for like 11 years. And I've never stopped to think, could I somehow contribute to Swig in a way that actually made the C++ better? Now, one of the problems that we have in our project is that it just takes a ridiculous amount of memory and time to compile and link all of these things. And yeah, I am using Conan for the dependencies. Conan is one of the more popular dependency managers at the moment, Raphael. And so I'm looking at these C++ files here. So I have this, so I can pull this up. And this is, it's ridiculous. I mean, we're talking hundreds of thousands of lines of code. This is 222,000 lines of code. Now keep in mind, this is one PyBind 11 because we're generating Ruby bindings and Python bindings and C# bindings and Java bindings and JavaScript bindings. So PyBind 11, not the solution here. Swig is the only solution for this code. And honestly, I'm not even sure if PyBind 11 could keep up because we're wrapping hundreds of thousands of functions. So having some way that does automatic parsing of these things of our header files to be able to generate these bindings. It's a very large C++ object model that we want to have like 100% parity for using that from all of these other different scripting engines. And like I said, I started thinking, well, can I like go into this and make some of these things better? Is that going to be possible? Yeah, so that's one reason why I wanted to get the overlay working, was so that you all from the Twitch/YouTube world can see each other. Now, it should be possible with the setup that I have to actually be able to automatically relay the chat messages between Twitch and YouTube so that you can see each other's chat messages in the other's natural environment, if you will. But I haven't, I don't know if that's working yet or not. I know you say you can see it in the overlay. It'd be pretty cool if you could actually see it other than that too. And this restreamer that I'm using supports like 30 different streaming services. So we'll see how this goes. And I have my upgraded laptop. So I just want to give a quick shout out to all of my patrons. And I'm guessing there's at least a few of you on here. I'm showing 100 viewers on YouTube at the moment. So just want to say, shout out to all my patrons, because without you all contributing to the channel, there's no way that I would choose to, keep all of this hardware and everything up to date so that I could make the best use of all of this. So my new laptop has got 8 cores, 16 threads, 32 gigs of RAM. It seems to be keeping up like a champ. I'm at 5% CPU usage. Even though I'm streaming at 30 frames per second at 1080p. So I think this is pretty good. All right. That's cool. Yeah, you all share with each other the Twitch and YouTube versions. Excellent. All right, so I'm digging into this code. It's 222,000 lines of code. Now keep in mind, this is like I said, this is like one of like 20 swig files that we generate. This is a medium-sized one. We're generating at least 4 million lines of C++ code. It's absolutely ridiculous. So the question is, can we make it better? And what will we gain if we do make it better? And I pull up some of this stuff and I immediately see code like this, right? This is ridiculous. We're using at least C++ 11. Hi, Ollie. Joining from Twitch side. Awesome. Great. It's funny actually to see my numbers. I see a couple of people drop off from the YouTube stream and a couple of people join on the Twitch stream. So that's awesome. Like, if I can go in and I can update these generated files so that this is just using auto right here, like, how much of a win would that be in generated code size? How much of a win would it be in compile time? How much of a win would it be in binary size? Like, I don't even know. What are the possibilities here? So I want to play with this and see where we can get. Now, I have us set up in a world where I can relatively easily go and with a quick find command, delete all of the C++ files and object files that are being generated here. And then I can, with Ninja, just say, okay, rebuild just that OpenStudio model core. Now, I am connected to my virtual machine that has a lot of processing power for this kind of thing. I didn't want this to bog down the stream or anything like that. So you can see about how long it took. Now, it generated the swig file pretty quickly. The build happened instantaneously because Ccache caught it. I'm going to leave Ccache there, so we don't have to wait every single time we go to build, although we could clear Ccache from time to time if we want to see what those results are. And with an ls, like I said, we can see here this is a 10 megabyte source file, a 51 megabyte object file that's generated for a debug thing. Now, each of these object files actually all have to get linked together into one gigantic executable. It's absolutely crazy how large, how much work we ask the linker to do, which means that it often takes several times to actually get the project to complete, to link and to generate an executable, because there's a very good probability that you're going to try to link too many large object files at once. You're going to run out of RAM, and then your linker process is going to get killed. So you might get like 2 files that successfully linked, and then you have to restart the build so that it can try to link the next couple of files. And it's absolutely ridiculous. So we're going to see what we can do here. Now, I have a local checkout of swig that is compiled, and I have done a quick hack of the main project. So instead of using the Conan provided swig, LTO can do some things here. It doesn't make a huge difference, but it can. Yeah, all of the external libraries are static inside the CXE2. This was a decision that was made a little while ago. It's possible this project is actually going to split these things back up again into multiple libraries, but at the moment it actually does get all linked. It gets linked twice. It gets linked once all into one executable, and then it gets linked a different time into shared libraries that can be loaded by an external Ruby. So we've got a binary that has Ruby embedded with all of the DLLs for the swig bindings that we're generating, and then we have a separate way that you've got all of the shared objects that are generated so that you can use your system Ruby to load our libraries. So it's a little bit complicated, and we're not going to talk about the history of how we ended up where we are. Can you tell us more about, right, the exact moment that I say that I see the message, can you tell us more about the background story of the project, like why? Okay, fine. I'll give you a little bit of background story. This is an open source project funded by the Department of Energy. It's a National Renewable Energy Lab project. And the National Renewable Energy Laboratory in Golden, Colorado is one of the main funders of this project. And you can go look up what OpenStudio does. OpenStudio is the name of the project. You can easily find it on GitHub. You can look up the project yourself. So we are just going to try to see if we can make this generated stuff better. But the reason why we have all of this stuff exposed to Ruby and why we're using swigs, because we knew it was going to be a very large object model from the very beginning. So swig being an automated wrapper interface generator, that's the natural choice. We knew that we needed Ruby from the beginning because this was originally written as plugins for SketchUp, so that you could actually design a building in 3D in SketchUp and then run an energy modeling simulation of that building. So it's a really cool project. And just for transparency, I'm not being funded to work on this project at the moment because I have other priorities that I need to be spending time on. So I am just choosing to say, well, can I make Swig better in a way that would impact this project, and what would it mean? So it's Ollie messaging from both Twitch and YouTube. Are you gonna? What kind of dissonance are you seeing, Ollie, between the two different streams? Yeah, so you're all going to have your own little language wars thing about C# versus C++, whatever. I don't have any control over that. So yeah, that's a little bit of the background of the project. It's a large object model. It needs something like Swig to generate these bindings for us. It needed Ruby historically. Now there's momentum behind Ruby. There's an awful lot of momentum with code that's been written for Ruby that uses this library. All right. So I have this set up where I've got this hooked in here, and I've got just a minor change. I put in a comment, Jason was here, in the ruby errors.swg file. So I can see that this comment, Jason was here, did actually end up in the generated file, and the generated CXX file. So I had to do that as a sanity check, right? Because we don't want to start changing a bunch of stuff and then not have the output wondering, oh no, did we have the right executable? Do we have the right swig lib path? Do we have whatever? Huge pain. So did that for a sanity check, and now I know that I can add stuff in here and it gets put into the generated file. So there's a bunch of template code in this Swig world where it says, okay, if you want to generate a wrapper around a standard vector, then this is the kind of thing. And when I say template, I don't mean C++ template. I mean their own templated language. And the templated language that they wrote takes these code snippets and says, okay, if you've got a standard vector that you want to expose to Ruby, here's the code that you need to do to be able to translate all of the types from a standard vector, whatever, into something that Ruby can work with. And so when we're in this code, we start to see this stuff. And like I said, I'm going to see like one step at a time. We're going to see what we can make better. Now, the first several thousand lines of code is all boilerplate. It has absolutely nothing to do with my code. This is all just pound defines that Swig needs. This is data structures that Swig needs. This is type checking, type conversion, so that it knows if you've got this C++ object, this is how it's going to convert it to Ruby land. It's got these dynamic cast things, client data, things for mangling and unmangling type names between different things, packing and unpacking data. All of this up to this point is boilerplate. This is never going to change no matter what library you are exporting. I'm going to assume at least C++ 11. We might go to C++ 17, depending on what we see and what we can do here. So this stuff, like I said, this is all just boilerplate. And Swig table trackings, Swig Ruby trackings, Swig Ruby internal things. All right, Ruby append output. We're still in boilerplate code. Boilerplate pointer handling, define class. This is the kind of code where it actually, in C++, we specify a new type, and then it can tell the Ruby runtime, here's a new type. All right, so still in boilerplate land. What are we, like almost 2,000 lines of code in? Packed objects is callable. Okay. Swig director. All right, now this is the first thing that's going to start to get to code that is optionally in here. So if you enable Swig directors, you can actually do this really cool thing where you can specify a class in C++ and then derive from that class in the target language. That could be Ruby, Python, C#, Java, whatever. And then once you've made a derived type in the scripting language, you can now actually pass that back into your C++ code via a pointer or a reference. And it just kind of does the right thing. It marshals across languages in an inheritance hierarchy. Now, to do this, it has to generate a bunch of code. So the swig generator has to generate a new type that derives from your base class that it can then use to marshal with between the scripting and the C++ world. So this swig director, this is the first time that we're into something that we might want to touch on. So this like GC item virtual, GC item destructor, I could just explicitly equals default that. But again, this like what I'm going to start looking for is the thing that is not just a copy and paste boilerplate, but the thing now we're starting to get to it. So this is our swig types table begin here. And from the visibility of this one project, we have, this is just one piece of what we're doing, keep in mind. Uh, 414 types that we are exposing to swig. It's 414 types that we're exposing to swig. Yeah, so at this point, to answer Hybris' question, if you were actually, if you were wrapping a C interface, yeah, I mean, all of this is boilerplate up to this point. It would still generate this much code. Now, where it starts to get into the multiplication of code, this is boilerplate, working our way down. It starts to become obvious when we get to the stuff that is specifically generated for our library. Here we can start to see that's including our header files, which it's weird to see pound includes in the middle of a C++ file, but yeah, that's what it does. So it pounds includes all of our stuff after it got past all the boilerplate and whatever. And where are we need to end up? All right, set slice. So this is still boilerplate. So this is stuff that's been copied and pasted in. It could be better. We could be using auto decals. We could be using, instead of standard advanced, we could be using standard next. We could simplify a lot of this code. But if it's code that exists exactly once in this file, I'm not too concerned about it. I'm looking for the thing that gets multiplied over and over and over again. And then we'll get there. I was actually there at the start of the stream before I realized that I was live with my stream. Have to figure out how to do that. How to go live when I'm ready to. All right, I'm gonna start skipping down. All right, here we go. So now this is the code that's generated for me. This is because I have asked Swig to let a vector of models be accessible to Ruby, to Python, to whatever. I'm looking at the Ruby bindings at the moment. And then this is where I start to see this code that is going to be multiplied over and over and over and over again, where it's doing things like I equals self arrow begin, E equals self arrow end. And then it's doing a what? For nothing, while I does not equal end, increment I, comma equals true. Okay, so it's doing some sort of inspect something or another. So I need to look for this code, like I equals self arrow begin, and see what we can find. All right, so we can start to see it's looks like it's in here. Ruby container.swig. that's in the each block. This is, I'm looking for an sequence each slice. Sequence methods, non-resizable, common containers. See what I'm trying to say when I say that it's its own template language? There's all of these things in here. So define swigs, sequence methods, non-resizable, common. So this is a macro that is going to be called from who knows how many other places. And this block of code is going to be implemented in who knows how many other places. So let's see. There's the each function. Okay, so there's the each. That looks right. So we found the block where each is implemented. And if we scroll up a little bit, that is the slice function. Okay, so it's this macroed, templated, stamped out thing that happens over and over again. So I'm gonna start just like hacking on this stuff. And if anyone has any comments along the way, please let me know. This sequence : const iterator, if I look down in the each, we can see this actually gets expanded out to the full type name, const iterator. And that's just like big, right? So let's make a quick test and let's just say what happens if I just do this in one place. Let's see if we're on the right ballpark. So, or in the right ballpark, not on the right ballpark. Let's delete that because I'm deleting it, the generated files explicitly, because I don't expect that CMake and Ninja and Swig and all those things working together can really like actually be able to track the dependencies of all of the Swig files all the way down. Yeah, assuming there was no conversion from the right-hand side, that could like actually be a really big deal here, right? It could actually make the code not only just smaller, but better. So I'm gonna go ahead and tell Ninja to recreate this one wrapper file. It's the name of the project that we're wrapping is OpenStudio, and it is a building energy simulation modeling system. I don't know if we're going to see a place for C++ 20 or not. We'll see. All right, so we changed just that one teeny thing. Let's see what kind of impact it has on the generated output as soon as this is done building. Yeah, so like I said, this is like one of 20 wrapper files, and before we cheated because it was already in Ccache. But we don't have Ccache working for us at the moment. Yeah, let's go for modernized loop syntax in a minute. I just want to see if we're in the right place. That's all we're looking for at the moment. All right. So by making that one change, I cut 54K out of the C++ file, and it actually reduced the binary size by 4K also. At the moment, what compiler am I using? Does anyone know? Userbin CC, userbin C++. So I'm using the system default GCC at the moment. .5.0 GCC. This particular project uses as its baseline operating system is LSB release. Ubuntu 18.04. It's definitely out of date. I'm not going to make any arguments there. But this is the version that the project says it requires at the moment. It can work with newer things. This is the setup that I've had, because whenever I'm working on this from a client code perspective, I always make a point of using the operating system that they say that they require, so that I'm using the same require that I have used for a long time. What do you mean, what is the broadcaster doing? Is there a problem? All I see is the last comment asking what was the broadcaster doing. Oh, no problem. Okay. All right. Weird. All right. I'm going to have to see how this all looks when I'm done. So the title actually says multi-streaming with Stream.io. Is that what I'm looking at here? Let's see if I told it to change the title of the stream, but it didn't. So, all right, so I actually have a view into the YouTube world now also, to make sure that everything looks good from that perspective. I don't have a view into the Twitch world, so hopefully that looks good. All right. Twitch title's fine. YouTube title is off. Okay. All right. So we are, we've made one teeny tiny little change, and it made some fixes. Okay. So this one does swig from value type iterator RB yield R. All right. So this does look like this could be a ranged for loop, and we can limit the scope of R. And it's got this mixed tabs spaces world, which is just going to annoy me to no end. But let's look at this. So that was using a const iterator. Self arrow begin, self arrow end. So maybe I can dereference self like this. And then we can do wait. Swig from sequence. Okay, I'm gonna have to leave that in place because I have to pass it to another template. So should that work? No, the range-based for iterator does not calculate the end iterator on every instantiation iteration. It actually saves it at the top. But the compiler generates the code for you. I do hate tabs, but I also hate mixed tab spaces. That's where I really get annoyed, because I mean, look at this code, right? This one is spaces, line 625. Line 629 is a tab. They're the same indent. It's just bad, in my opinion. In unclosed paren, okay. Enclosed paren and a duplicated W. So, yeah, but can we do cling format on this .swg file that this is this mixed world of things? Maybe I can do in a highlighted section. Whoa. Do a neo format pass? No, it doesn't know how to do it. Yeah, all right. So I think we made the each function a little bit better, and I feel like this is kind of gonna have to be baby steps. I'm just so curious, like how much do these tiny little changes, how much possibility uh, of change could they have here? Who is Turner NL? Is there a Dutch Turner saying hi? All right. So this code is going to matter because it gets multiplied. This code exists for every single vector that's exposed, which is a lot of vectors. A lot of different types of vectors, that is, different template instantiations of standard vector. That compile seems to be exceeding. Yes, the stream is live on Twitch also. I'm attempting to learn how to do multi-channel streaming here. It looks like I've got 175 viewers on YouTube and 20 on Twitch, which I think is a pretty good start for my first time streaming on Twitch. But I told people that I might be doing this someday. I just kind of want to know if we're going down the right road, right? So I just made the binary I made the executable another 2K smaller, and I made the binary a little bit bigger, actually. It looks like the binary got slightly bigger. For better or for worse, I don't know. The compiler's doing something with it. All right. I'm just going to keep going down this road and see what happens, as long as it keeps compiling. Ah, okay. I saw the comment from Turner NL here. Variance and vectors of variance. No, I don't think we ever went down the variant world, sorry, in any of this code. I do not use Rust professionally, no, to answer that question. All right, let's see what we can do. I want to look at I want to keep my eye on what the generated code ends up looking like. This is a sizable common. Oh, no, wait, select is the name of this generated function. All right, so just to keep an eye on what the generated code looks like. This R, that's a pointer to a newly allocated vector. Why are we allocating a new one on the heap? There's probably a good reason, and that's probably because we're going to pass off ownership to someone else. So we're not going to change that aspect of this code at all. So we create a new one on the heap, and then we're iterating over ourself, and we're inserting what in the world is this code doing? Self insert at the end of R? But R is an entirely new one that's not related to us at all. The value at the current iterator. That code looks completely broken. Oh, I'm streaming into the void. What can I do here? Let's see. Update title and more. Twitch title, category. You said science and technology? Okay, hopefully I got that Twitch thing going. This code looks like broken enough that I'm not going to touch it. I have no idea what that's doing. Delete at. Let's look at that one. get the position of an index, get an object of that type from that object, and then erase that object, and then return the deleted object. So this is, I guess, so that it feels more natural from like a Ruby world or something like that. But return R. It's interesting to me to put the code out here. Let's see, we do need the, we can make this auto. Actually, let's at least make things auto where we can, huh? So that's auto. For the person asking, why don't I use a syntax highlighter? It's because I'm editing a .swg file. So, you know, it's a swig file. I could put it in C++ mode. And look at all the warnings that I get from Vim. It's got trailing spaces and mixed indent files. Oh no, what do we do? Yeah. That's a good point though. We could at the very least like chop out so much stuff if I did this. Even in the code that we don't understand, could make the binary so much smaller. Yeah, this one just looks broken. Does it catch and then return R? Yeah, if there's an out of range error, then it still returns Q nil. That's what it's doing. This is how I would write this code personally, so it's more clear what the point is. Not consting things. This one I don't want to const. I thought I kept it with, let's see. Okay, I could const the end iterator. I'm trying to not break too many things. Line 664 should be, yeah, it was a pointer. It was a pointer for sure, so I'm just going to leave it as auto star because then it makes it more clear when you're reading the code that it is a pointer in fact, and we can see down here that it is a pointer. It doesn't change anything. I don't know, honestly, how changing the type to auto made the binary smaller in some of that code, but who knows? It would probably, the best idea is that it might have eliminated an implicit conversion that had been invoked. All right, let's see. You're saying the resize thing. This one right here, the select one, that's the one referring to. Lyrex. I'm just confused by this. Const.e can be declared inside for to limit the scope. All right, we're going to have... Now, we don't... Wait, here const.e cannot be limited, declared inside of... Oh, it could be declared. Here, you're saying. Yeah, I don't think that's going to give us a whole lot of advantage here. I want to kind of focus on the things that are going to have the biggest impact if I can. But yeah, that's a good point. Okay, here we go. Here's a bunch of 2s and 2a, and these things are just straightforward loops. These things should be ranged for loops, right? Yeah, these things should be ranged for loops. I yeah, I don't know. That's a good question. Tyrannosaur. I'm really reluctant to try to do anything that might change behavior. Oh yeah, switching to auto, change their type away from constant iterators, let the compiler decide formula. And there's no reason to be explicit about them having to be constant iterators because it all works out in the end. And if it saves build time and compile size, I'm good here. Temp moved inside a for loop scope. Yeah, I've had C++ weeklies about lots of things, right? So let's chip away at this stuff. I'm going to start on the easier ones. I'm going to start on 2S and 2A. So let's see. Just trying to think about where to get started here. No, wait, this is not using constant iterators for some reason. Let's do this. Surely there's a nice algorithm for that, and that is a very good point. And I thought about that as I was setting up to do this today. And I wondered at what point do we try to use algorithms versus just try to not have all these giant template things everywhere. And what is temp? Temp, right. You already commented on that. You collective view already commented on that. Oops. So I don't need I don't need E. I'm creating a new string object. I'm calling this buff append to it. Definitely a for each would work here. Many cases I find this kind of loop actually a little bit more readable. Isn't there cbegin and cend for const? Yes, there are cbegin and cend for const iterators. That might have changed some things as well. All right, so for those of you who are playing along at home, if you see any obvious, like, oh no, you should definitely have used this algorithm here, make sure you get my attention on that. Oh. Ooh. Okay. If I just did this correctly, the relay bot is now enabled. So when one of you says something on YouTube, the Twitch people should see it natively. And when someone says something on Twitch, the YouTube people should see it natively. So we'll see what happens when someone comments on that. Oh, that seems like it worked. The comment from Turner NL cross-posted to Twitch. Neat. Okay. All right. I am really liking so far this restreamer tool. is pretty awesome. I'm gonna have to. I can strongly consider paying for this so I get the rest of the features enabled, because that's pretty sweet. Maybe they should become a sponsor or something. Try to keep the same formatting that they use. Although I say the same formatting that they use, this is clearly code that's been worked on by different people over a long time, because there's different types of formatting throughout it. Actually, why am I forcing that to value? You know what? Just be auto. But I don't need the temp here, and I don't need the I, I don't need the E, and I don't need, I need that. Questions that I have are things like, should I get rid of the temp variable altogether? If it were my code, I absolutely would. I would do this in the cases where I can. Oh, that's a good question. What happens to the emotes? It says not like this on the YouTube side. It doesn't show the you holding your head like that. Yeah, for consistency, let's make it auto temp here too. And this variable is used in more than one place, so I can't get rid of the temp variable. Now, then I have the question of, should I make this const auto? And this is where I don't know if I'd be breaking the behavior of the code. I think it's time to do a quick kick this off in the background. Make sure I didn't break anything. All right, so this one is big. What is it doing? Inspect. So this is like if you wanted to inspect the object from a Ruby perspective, it's going to give you the open bracket and then a bunch of values and then a close bracket with comma separating. 2a still references I and E. Does it? Oh, sorry. Oh, that's interesting. Hey, look at that. It still references I and E. Who knew? All right. Making temp auto could change. Maybe that from template from returns a variant like thing, and assigning to a typed variable forces conversion. No, it's not that fancy of code. I know where you're going with this, but I don't expect that that's going to be a problem. Excuse me? Which one is still referencing I and E now? Oh, it didn't know that it needed to regenerate. I needed to explicitly delete it. .571 uses size instead of distance. Yes, that's what I got that. Sorry, I missed your comment, Vortex, but I see it now. So apparently one of the features of this restreamer that I could use is text-to-speech. So I could actually be listening to everything that you all are saying right now while I am editing, and I don't have to keep looking up. But yeah, I'll have to play with that at some later point. Oops. There we go. All right, let's dig into this inspect function now. So I and E are not used in more than one place. Temp can have its variable scope reduced. Let's start there. We've gotten used to that. Bool, comma equals false, comma equals true. If comma, then put the comma here. Okay. When do you set comma to false? You don't. No? Oh, on the first loop iteration, comma gets set to true, and then commas get added after each iteration after that. Not the clips, the temp on line 586. Yeah. No, I can't. I don't think I can because it's used in multiple places. I feel like I'd have to completely rethink the way this code is. Oh. Okay. I need to install an ad blocker. It's not an obvious answer. I see what you're saying though. You're saying this RB object of string is returning a new object taking that temp. So they're just using the fact that temp happens to be a value object. So that is tempting. This is where I start to wonder, does this actually make the code better? But in a way it does, because I was completely confused by the fact that this temp was used multiple times. STD copy with make ostream joiner. Yeah. The problem with that is we're not creating a C++ string, we're creating a Ruby string. So I don't think that there's as obviously straightforward way to do that, Nicholas, but I could be wrong. I'm definitely willing to be proven wrong on that. All right, let's see where we are. Look at this. How many thousands of lines of code that last error had in it. All right, 51032. Let's just look at that. 510. So interestingly, actually moving to these ranged for loops is actually making the binary bigger as it's making the source file smaller. That is actually very interesting to me. Now, what was this last comment? And then make it standard accumulate. Make it a standard accumulate. Make it a standard accumulate. So you're suggesting I want to accumulate. Might be able to make it an accumulate. All right, well, I'm just going to start cleaning this up. Let's just start there. So comma is equal to true after the first iteration. And then otherwise, this is a ranged for loop. what is this? Swig type name, car type name. So it needs the type name. Okay, it needs the type name. I can't do anything about that. And this is where it's creating the new string that it then concatenates all of the things onto. Concat, concat, concat. Then we see the same usage of the temp sequence from inspect chain before. Regarding to 2s, it assigns a new loop. Yes? Oh, okay. Yes, I did get my new laptop. And I can just try to point down at it briefly. Nope, my background erasing software is going to give you a hard time for that. It is a Lenovo ThinkPad X13 with a Ryzen 7 Pro with 8 cores and 16 threads and 32 gigs of RAM. And so, yeah, I already made a point of thanking my my patrons for that, because I wouldn't have gone through this effort of creating this, of upgrading all this stuff without their support. Yeah, so this self thing is part of the templated code. So let's go find the stuff that we've been working on. This thing that this $self is in the swig generated code. And so it's whatever is passed in to the swig generated function. A 13-inch laptop screen is what I prefer, because then I can narrowly focus what I'm looking at any given moment. Yeah, I still run Windows as the host and Linux as VM. That's just how I prefer to work. I know that all the tools that I want to use are just going to work on Windows. And since I'm a Microsoft MVP, I have access to all of Microsoft's tools too, so I don't have to pay for that stuff. But yeah, I actually prefer a small screen, because it helps me focus on one thing at a time instead of being distracted by a bunch of different windows all over the place. So what you're seeing is pretty much how I work. So this file is now 221,000 lines of generated code. It should be $self instead of $self. Oh, did I do a mistake somewhere? Yes, you're right, $self. Okay. $self. Okay. So it would be nice if we could somehow clean up this value type from thing. Swig from value type. Where is this even? There we go. What is a more succinct way? Wait, swig for, I'm passing it something of type, value type anyhow. So function template argument deduction should already be coming into play. Why are we explicitly passing the value type? I'm passing a reference to an object. So if I pass the reference, then it should call that version for a const reference. The end there, I don't know if there's an end goal. The end goal is trying to see if we can make the swig generated code more readable. That's the ultimate goal. I am so curious why we're explicitly passing that type here. Function template argument deduction should just do the right thing. Sorry, I'm switching around all kinds of places. Yeah, it's gonna look sketchy, but it is all managed internally in its own garbage collection hooks into the Ruby garbage collector and stuff. It's a function template. So function template argument deduction's been around since the beginning of C++'s template world. That's weird. I'm not gonna touch that yet, but that's weird. That makes me wonder why that's there. All right, so we've done some things that are definitely more succinct, if nothing else. And I'm a little surprised that we keep making the binary bigger. That's the stuff that we know exists. And you can see here, external interface variable vector slice, external interface variable vector 2a. The number of times that we've got external interface schedule vector, external interface function mockup unit import to whatever, like it's just crazy. All right, sorry. All these tables are all of these tables are how it actually exposes each of these functions to the Ruby runtime. So all this stuff has to happen once it starts up. All of this is all the startup code. However many hundreds of thousands of lines of code that is. Which makes me wonder if some of that could be simplified, but I don't think so. It's all very straightforward. Ruby define method on this class. This is the name. This is the function that you need to call. This is its position. It's all very straightforward. Whoa, 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 whoa. More tables. So many generated tables. All right. I wanted to get back to this last slice function. Yeah, this function. Oh, someone asked how big is the swig file. It looks like it's 1100 lines. It's not huge, but this is only one of many. Yeah, this one's 1100 lines. Yeah, the question of maybe they didn't understand that the compiler figures out what is being passed, or maybe it's because Swig has been around for a very long time and they needed to support older compilers, or maybe it's because of a few corner cases where without explicitly passing it, they don't get the specific conversion that they want. And it's the third case that makes me reluctant to change it, because maybe there are a few corner cases where I would break something if I changed it. I don't know what I was looking at. I'm gonna need a drink. I'll be right back. Yeah, there's tests. And I probably could run the test and see if I broke something. That's a good point. Let's see what we've got. Um, Thought there were tests. No, it's not in the lib folder. That's where I just was. And I don't see anything called test. Huh. What's going on is I'm trying to see with y'all's help if I can simplify code that is generated with Swig for Ruby bindings. That is the goal. And this is working from a very large project that has a huge amount of Swig code that is generated. No one answers your questions. Can we make framework like Flutter but by C++ for us? I have no idea. I don't know what Flutter is. All right. We were looking at which function? Slice was what I wanted to try to figure out next because this is a very big one. And if we could get it a little bit simpler. What is this? Like it's doing a vector difference type static cast of val2. val2, val2, val2. What is val2? val2 is a pointer diff t. Okay, so it's this I'm sure exists to avoid warnings on other platforms. This reinterpret cast is probably necessary because of the bridging between Ruby and C++. This is necessary. I can't reduce that. I could reduce some of the scope of some of these variables. Thanks, John. I'm on Twitch today also, John. For the first time ever. So if you want to join me on Twitch, instead you can. And I'm using the, what is this called? Restreamer, which is automatically linking the messages. So when people post on YouTube, they automatically get relayed to Twitch and vice versa. So it seems to be working out pretty well at the moment. All right. Wait, why is this, what is this, a different 2s? Didn't we already clean up 2s? Convert class to a string representation. All right. What in the world? Why does this feel like deja vu? Which inspect has a reinterpret cast in it? At the moment, I'm not going to make any specific judgment, but I feel like Restreamer might be better than StreamYard because it also gives you some of the StreamYard capability. I just noticed on YouTube that Mini-Me is right over my own head. No one had pointed that out yet. Let me see. I'm just going to drag myself a little bit to the left. I shouldn't be bothering too many things if I do that. Yeah, there we go. Now I'm not on top of myself. Now I'm beside myself. All right, so I want to find out where some of these reinterpret casts are. They're everywhere. Why? What am I looking at? Shared pointer, shared pointer, shared pointer, type maps, swig macros, swig types. Is that a macro that's getting invoked? And I mean a swig macro in this case. This inspect function is a for loop. It's some other level of inspect that's happening here, I think. I'm gonna regret that. No, I'm not gonna regret that. All right. Standard pair, Ruby container, that's the one that I was just in. Multi-map, standard map. Swigars, Ruby classes? This is where I'm actually inspecting the class, not the object, perhaps. Yeah, reinterpret cast all the things, right? That's what's gonna happen next. No, the compilation succeeded. I'm just trying to look for the next thing to clean up. You can go look up swigs. Swigs is the simplified wrapper interface generator. It's used to generate a huge set of bindings for from C++ to Ruby in this particular case, but it exists for all kinds of other things. That's not the inspect that we should be looking at. Now I'm just really curious where this function came from. That's all I'm doing right now is trying to figure out where this function came from and see if it's something else that we can address. It would be interesting to see why the ranged 4 increases the binary size. Oh, I know why the ranged 4 is increasing the binary size, because I'm making debug builds. So I'm not actually at all surprised that it might in a debug build, given the setup that happens around a ranged 4 loop. I'm guessing in the release build it's the same or smaller binary. There might be other symbols being generated that we're not aware of, all kinds of things. I think that's probably what's happening here. I really just want to know where this inspect function is coming from now. That's a vector, and it's an inspect function. And I just grabbed all of the swig source for inspect functions. And it's not here. Oh, wait. Ruby container. Okay, yeah, Ruby container. Map. Multi-map. Yeah, no, that's not that one. I am so confused. What is going on, by the way? I keep seeing a pop-up come up from something, but I don't know what it is. I don't know if it's something from my restreamer integration or what? All right, maybe we'll just move past that. I'm really curious where this code is coming from. V result equals Q nil. Maybe that'll give me a hint. Oops, wrong window. This code doesn't exist. Where's it coming from? What in the world? All right, fine. Moving on to other things. Create a duplicate of the class and unfreeze it. Yeah, this is all the class, how classes are exposed. That is what this is that we're looking at. How classes are exposed. These are all the class objects inside of Ruby. Oh, stop doing that. I think it's the same. Capital R versus lowercase r. Huh. That is definitely what I'm looking at, and I find it annoying that I cannot figure out where this code is coming from. Oh, come on. Aha. Aha. It's hard-coded in the C++. Of course. Oh. Okay. Oh, this is in the core of the director code. What? All right. No, just gonna... Yeah, that's what's happening here. Oh my goodness. All right. Yeah, I'm just gonna try to get back out of this code that's being generated straight from C++ and try to get back into the .swg file generated code. I got a little too deep in here, I think, for our first foray into this. Size, swap, begin. These all look like good candidates for this kind of thing, hopefully. All right. Oh, right. Sorry about that distraction here. All right. Slice. We haven't looked at this, have we yet? All right. Resizable common. Delete at. Okay, we started to look at some of that. Sequence containers back inserters. Delete if. Get item. Ooh, what is that? At. Get item. Okay. All right. I'm going to start approaching some of this stuff. You all seem to just be having your whole own little conversation right there. That's fine. I'm gonna see if I can just keep going down this road now that I got lost for a few minutes. Get item at I if I is less than 0. Okay, all right, so it tries to loop back around like one would expect for a Ruby container. So this sequence difference type of length plus I. Length is already difference type, and I is already difference type. So that's no, I can't make that const yet. And then a static cast of difference type from len. That's fine because that's size t up here. That's going to be necessary. R is equal to q nil. So we want to actually try a return from here. Otherwise, we want to return q nil. That should work. Hey, I'm glad I could be a help. Kroisk. Kroisk? Just a guess. All right, so that's a pretty minor change here. Let's see. If length is less than 0, return q nil. Try to wrap around. I, auto, J. All right, that's a little bit of a change. And this one is just the difference type here. So let's try that. These are just tiny little changes. I don't expect these to have a big impact. Oh, this get item is little disconcerting. What am I looking at? Static ID. There. All right, that's what this get item is doing. So it looks up the begin, the end, and the exclude end once and tries to save it. Yeah, I thought about doing that const auto j with IILE. I did. I didn't. Yeah, all right, fine. I don't know if this is going to have the end result of actually making the code compile faster. Oh, actually, no, that's going to be hard to get right. I'm going to leave it. Oh, yeah, I'm going to leave that. I don't like these static globals in here, but I don't know if there's anything I can do about them. That's a lot of logic. Let's look back at this generated version of it. Man, I wish we could simplify these swig from things. Oh, all right, min of length plus, all right, fine, I'll get back to it. All right, let's see. Does that look right? The Twitch audience right now is 17. I had 25 at the peak and 174 on YouTube, but I just have a bigger audience on YouTube anyhow. Could the statics be const expr? No, they can't be. They are things that have to be looked at runtime from the Ruby runtime. There is no way to make those const expr. The names of these functions alone is just something else, right? I mean, they're generated names, but it's still just something else. This is a standard vector of OpenStudio model external interface variables. I really want to use a C++20 just like auto parameter for the difference type. I really do, but I can't do that. Do I have a static cast? Static cast? The YouTube should be streaming at 1080p. Hold on just a moment. It says I've got excellent condition. Although YouTube is being a little bit of a pain. So they've been streaming for an hour and 36 minutes. So yes, I guess it's probably worth doing a little bit of a recap here. Let's go ahead and exit this. This is one of about 20 swig generated files that we have in this project. It is a project that I have been paid to work on for more than a decade, but I am not being paid to do this work at the moment. I just thought it'd be interesting to look and see what the issues are. So we've got, for a debug build, this is a 10 megabyte generated C++ file and a 51 megabyte generated object file. So I'm just trying to see if I can make some of this smaller, simpler, better C++ generated code. I wanted to see kind of what the impact would be if I could clean up a few of these things from in various places. So what about using an alias to the name for something more cleaner and concise? What window manager am I using? Yeah, so that's one of about 20 object files. So that's, yes, they're huge. They're huge. The biggest one is more than 2.5 times the size of this one. So I just wanted to see, like, well, if we modernized some of the generated output, could it have a noticeable impact? That's all. And some of this stuff, yeah, could I use an alias? Maybe. I'd have to create my own namespace with the aliased types in it or something. Or, oh, wait, well, let's see something. Ooh. Yeah, that's the like exact same code all over again, isn't it? So this stuff gets multiplied hundreds of times. This project is very large for the amount of code that's generated from Swig. And so the hope, the general like thought process for me here was, well, if I can go in and I can clean up just a couple of little bits here and there, and then have that multiplied hundreds or thousands of times across the project, what would we get from that? And we're definitely starting to see little things here and there. So this sequence here, we're starting to see like the same kind of patterns repeated, I guess is what I'm trying to say. We've managed to make for each loops out of a few of these things. This one could be for each loop. I haven't, well, it's generating 200,000 line files. I mean, the object files are big because there's a lot in them. I don't think it's much more complicated than that, really. All right. So just going in and finding random bits and bobs from here and there to mess with. I'm tempted to put this in release build mode to see what we find different there. So I'm going to do that and then kick off another build while I continue to... Sorry, I'm just doing a scroll back because I thought it would be faster than going to the downloaded version of CMake that I have, but it wasn't. Return equals valid code. Oops, did I do that? No, that's not valid code. Yeah, so using a local alias, maybe I'm just gonna scroll through and find one of these bigger functions, like this get item here. And let's see, no, that one doesn't. I'm looking for things that use like sequence : like several times inside of one function. Now someone commented an anonymous namespace. No, I can't safely do like outside of one of these functions a difference type or whatever. Let that do its thing while we continue to look for. Right now I'm kind of, well, I've been doing this for a couple of hours now. I'm just kind of looking to see if something jumps out and says, well, clearly this is a function that should be approached. And now I'm just in the container code, right? Ooh, here we go. Ooh, 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 ooh. Let's see what happens. That's a good one. All right, cool. I'll have that built in a second here with the release build. I'm going to do a quick stash of my changes to Swig so far, and just see what kind of impact we've had to this point. Well, I'm gonna make sure this compiles. That could be pretty big by itself, possibly. Uh-oh, what did I do? Did I mean to set sequence type to value? No, 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 no. No, I meant to actually, because that capital sequence is a copy and paste in the code. And that's where we're seeing the whole type name duplicated like 15 times inside the code. So it's a start to trying to just reduce the uses of some of these things. Although this actual, why is this iterator start here? I'm just trying to, like I said, I'm trying to reduce the size of the generated code and to see what impact that has. That's my main goal. Make the generated code a little bit more readable if possible as well. Although some of these things here, What we had done starting out on a lot of this stuff had just been putting auto in places. And reducing a lot of those uses here. All right, so this is now the this is now the optimized version. All right, so it's still a 10 meg, and now we've got 111 meg object file. All right, that's fun. Let's all right, I'm gonna take a real quick break, and we'll see what that looks like when I get back. Yeah, yes, I noticed that. Could use next instead of assigning and then advance. Let's look at that when we get back. Oh no, we broke it. You probably already saw that, huh? I'm back. All right, how did we break it? How did we break it? Line 22249. 2224. 9. Oh, it was in that min. Oh, it's the static cast that you told me that I had done. But I'm... All right. Yes, yes. Someone told me that, and I missed it. Sorry. Thank you. All right. Let's see if we can wrap this up. I'm going to, I don't know. We're going to see if we accomplished anything. And then I'm going to, I guess, wrap this up for today in a few minutes here. Okay. That would be the exact same error again. Oh, that's because it didn't regenerate the Ruby file, or the swig generated file here. Oh, what happened to the RPG game that I was developing? You know, it's still. I need to get back to it. I have plans. I need to get back to it. So, yeah, do I expect to come back this is another stream? I think I might. What we're gonna. If we see that we got somewhere. Oh, yeah. Sorry to mess this up here again. I want to see if we got anywhere from a RAM and time and size of binary perspective. And if it looks promising, then I might come back to it later. So we've got maybe like 5 or 10 minutes left here where I'm going to do a couple of builds, see where we are, and then decide whether or not this is worth further pursuing. That's the idea. Now, regarding the game engine, I do have plans for that, and I need to get back to that. But if you haven't noticed, I haven't streamed in a couple of months here, really. So I'm hoping this is a test of my new setup. This is a test of using Restreamer. It seems like that works. I really like the idea that I can have both Twitch and the YouTube community going at once. I think that's pretty cool. And then I'm going to be doing some more code review live streams and probably some more stuff on the game. Now, what I've decided, and I haven't announced this publicly anywhere yet, for the game engine, is that I'm going to take the work that I've done so far and try to make that into like the C++ weekly game development kit, kind of. So right now I've got the C++ starter kit that I've got. This is going to be like the C++ game starter kit. It's just going to be effectively a fork of the C++ starter kit. They're going to remain closely related. And then if you want to start with like the game stuff that I've done, then you can get a fork of the game starter kit, and you can see, have some basic place to start from with doing very simple GUI, not GUI, but graphical programming on the C++ from my starter kit. That's the idea, and we'll see where it goes. If you're a Twitch partner, they don't allow Restream. What? No, no one told me that. Why not? Why should they care? But no, I'm not a Twitch partner yet. I'm gonna have to look into that. That's unfortunate because I really like how this is working. All right. All right. I'm gonna make a. Oops. I'm gonna make a note to myself to look into that. Twitch partners have exclusivity agreements. Yeah, okay. I'll look into that. All right, so that took 2 minutes and 30 seconds to build. And let's do a look at what our generated binaries were. All right, so now we're going to delete those files. And we're going to stash what changes I had made to swig. And then we're going to rerun the build of that core file. There we go. And we're going to see what time, memory usage, and binary and source code differences were. Twitch partners have exclusivity agreements. All right. Well, I've only got like 50 followers on Twitch, and I haven't done anything with them yet. I haven't given them any kind of information from me, so we'll see what the deal is there. Let's see. How to become a Twitch affiliate without putting in years. This is a Restream blog article that I just found. The Twitch affiliate program puts qualified streamers one step closer. Twitch affiliate requirements. 7 unique broadcasts over 500 minutes to become a partner or to become an affiliate. After becoming a Twitch affiliate, you'll be faced with a tough reality. Twitch exclusivity policy stipulates that if your live content is subject to that all of your live content is subject to a 24-hour exclusivity period during which you won't be able to publish anywhere else online. In other words, you can't multi-stream directly once you become a Twitch affiliate. However, it doesn't mean Restream stops being useful to you. Quite to the contrary. Of course, Restream wants me to think so. So they're suggesting here that you could still, after 24 hours, just rebroadcast it on another platform. You know, I guess I don't see a world where Twitch becomes my main source of revenue. So if I am just still using Twitch to continue to kind of spread out, but never agree to the affiliate or partner thing, then that might be work good for me. I think I might just end up in the realm where I just don't agree to what they want and don't worry about it. Because I don't know. We'll see. All right. So, the pre-version used slightly more RAM, compiled in almost exactly the same amount of time. Although, interestingly, it was less system time and more user time. And if I look at this, the before version had a slightly smaller binary and a slightly bigger generated file. So maybe the road that I'm going down is not going to have as big of an impact as I hoped. Yeah. Thank you, Kayak and Tyrannosaur and whatever. I'll look into that further and I'll see what I end up deciding to do. And it kind of looks like my effort today so far kind of seems like it was a waste of time. We modernized some very commonly used functions and it didn't gain us a whole lot. So I don't know if this is worth pursuing further or not. Little disappointing. And almost everything that we have in here is these vector functions, I think. Yeah, I mean, it's so many things that were generated for vector, just hundreds of thousands of lines of code for different vector instantiations. Ollie, you just got back. I was gonna say, so this is the after I actually made the binary bigger. The source code file is actually smaller by a not inconsiderable amount. I mean, at least 100K. But the binary is actually bigger and the compile time stayed, I mean, like ridiculously pretty much exactly the same. I saved 0.3 and I didn't use any less memory. I used slightly less memory when linking. So I'm going to call this a failed experiment for the moment, but interesting investigation at the very least. Do an inimd Yeah, since you bring it up, I'm going to go ahead and do this. Kroisk. I think that there's probably... Where did that file go? Source model, CMake. I think there's a decent chance that all the hard work is in generating is in compiling and linking. No, it's not a debug build anymore. Sorry, it's it's the release build now. But it does make me strongly wonder if this is where all the hard work is in all of this stuff that is actually registering the code with Ruby, because it is so many tens of thousands of lines of code where it registers these things with the Ruby runtime, and then the tables of data. Now, some of the static table data could possibly be moved to constexpr. Maybe that would have an impact. It's all function pointers and compile time known string constants, so maybe, but then it needs pointers to those things later. So, yeah, probably just approaching the wrong problem. Yeah, I don't know. It's I didn't get any output at all. It just says no symbols. I didn't do it. That is definitely the binary that we were just looking at. All right, I'm gonna wrap it up here, y'all. Sorry that we didn't, I don't know, learn something more interesting, but I guess if anyone's curious about hacking on the internals of Swig, there you go. But otherwise, thanks for hanging out, and I'll catch you all in the next stream. So, later.